So this new chapter is solving systems. Now, solving systems means where two where two lines meet together. So, some ways to solve them. One of the ways we're going to discuss today are solving systems by graphing. So if I was looking at a graph, in a coordinate graph, and solving systems, it would be like where I have one here and one here. This would be where they would meet. Now, the problem is sometimes when they meet, you're not going to have whole numbers. But today's lesson is not going to be that way because you're graphing them, so they'll have whole numbers. But because that's not going to work always, we're going to graph by two other ways. Also, we're going to solve systems by using different methodologies to find out the answers. But today is solving systems by graphing. So we have to remember the one graph situation that we like to use to find it, and that would be y equals mx plus b. That's our our slope-intercept form to find out how to for us to graph those systems. So let's do some stuff. So we are going to, first of all, on example 1a, check whether 3, 4 is a solution of each system of equations and show your work. So that means, if you remember, this would be x and this would be y. So you have to plug them in to the formula and see if it will work. So if I did plug them in correctly, 4 would go in here, this would be 3 plus 1, and this would be 4 minus 3 equals 1, and we would check and see if it works. 4 equals 4, yes, that's true, and 1 equals 1, so this one would be a yes answer. Let's try this one. 3 plus 4 equals 4. And 4 equals 3 minus 4. So I would have 7 equals 4. Nope. And 4 equals negative 1. Nope. So this would be a no. And here's how you would get those answers. And showing your work is this is what they mean. Okay. Solve each system by equations by graphing. So first of all, I'm going to start with this one, the first equation. I'm going to have two different colors. So I'm going to start with b. Remember, we start with b when we graph. b is 1. M is going to be the number that's in front of the x. And make it a fraction, so it's going to be negative 1 over 1. So I'm going to graph it with red. So I'm going to find 1 on the y line. And from that point, I'm going to go down 1 because I'm going to put the negative with the top. So I'm going to go down 1 over to the right. And I am going to it's so hard to do a straight line. You will need, for doing your homework, you will need a straight edge. You will need to make sure you have a straight edge. Okay, for the second one, I'm going to use blue. You have to make sure it's y equals mx plus b, and it is. It's y equals mx plus b, so I can do b first. b equals 4. And m equals 2, but I need a fraction, so I'm going to make it 2 over 1. So I'm going to go up 4 from 0. 1, 2, 3, 4. From that point, I'm going to go up 2. 1, 2 over 1. Up 2. And then I'm going to graph it. Okay, so after you've graphed them both, then you figure out where they meet. And they should be a whole number. And they meet right here in the middle. Right here. And that is at -1 up 2. Up 2. So it's -1, 2 is where they meet. So your answer is -1, 2. That's what you would need to do is check each solution. That's what you would do. If you weren't sure, that's how you would plug that number into those two equations and see if it would work. Okay, B. Let's try that again. I'm going to do red first. So B equals -3, m equals 3 over 3, 1, sorry. So it starts at -3, goes up 3 over 1. There we go. Okay. Oops. One, 2, 1, 1, 2, 3 over 1. So that's the reason why you need a straight edge. It works so much better. Okay, then you have your second one. Oh, y is not by itself, so you need to put it by itself. So I'm going to subtract x to both sides. So y equals -x plus 1. So now I know that b equals 1 and m equals -1 over 1. So it starts at 1, goes down 1 over 1. Wow, it already hits a spot where they meet. And so that's where they're going to meet. So that's going to be 1, 0, where they meet. That's how you're going to do example 1B. All right. Suppose Stephen is testing 2 fertilizers on bamboo, plants A and B, which are growing under identical conditions. Plant A is 6 centimeters taller, equals 6 centimeters taller, and growing at 4 inches per day, centimeters per day. And plant B, I'm going to change the color. Plant B is 10 centimeters tall and growing at 2 centimeters per day. What is the system of equations for the height? As a function of days. So they have days on the bottom and the height. So the height depends on how many days it's been around. So you're going to make numbers at the bottom and the top. I'd do it by tens. 10. Oh, days, I would do it by 1 day. 1 day, 2 days, 3 days, 4 days, 5 days, 6 days. Height, I would make it by tens. 10, 20, 30. Maybe not. Maybe by fives. Start with 10 and then go fives. I'll do fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, and you're going to graph it. So you start with 6. And you go up 4. And go over 1. And you're just graphing it like a normal. Oh, that should be blue. Hold on. That's your blue plant. And for plant B, it starts at 10 and goes up 2 and over 1. And this should be purple. You'll use a graph paper, so you should be able to do it so much easier than me. You know, it didn't work very well with this way, so I'm going to do it by 2s. So let's do the blue plant. Well, I'm in purple already, so I'm going to do the B plant first. So it starts at 10, goes up 2 over 1. So up 2 over 1. So I'm just giving myself some breathing room. And then here it starts at 6, goes up 4 over 1, up 4 over, oh, well, it kind of already helps me right there tell where I'm going to be hitting it. Should be hitting it right there. So I'm going to say it takes in 2 days, they hit 14 centimeters. In 2 days, 14 centimeters. So I have just answered A and B together. All right, I'm going to put examples 3 and 4 on video 2. So 4 and 5 on video 2. So stop this video, go to video 2.